In this video, we're going to take a look at logarithmic functions. Please note that the log function is the inverse of an exponential function. So if we look at the graph for y equals 10 to the power of x, as you can see, as x gets bigger and bigger, y gets bigger and bigger extremely quickly. That's why we say things grow at an exponential rate. And what we mean by that is they grow very quickly. And why is that? Well, if we look at the equation for y equals 10 to the x, when x is 2, we get 10 squared, which is equal to 100. When x is 4, we get 10 to the power of 4, which is 10,000. So as x gets larger, y gets larger much, much quicker than in any other type of graph. So that's why we call it exponential growth. The log function is the inverse of the exponential function, and as you can see, as x gets larger and larger, y gets larger, but in the opposite way. It gets larger very slowly. If you follow the graph, it looks like there might be a horizontal asymptote, but there isn't. It's as x gets larger and larger and larger, y will get larger and larger and larger, but it will just get very slowly. So if we look at the two graphs, the exponential graph always goes through the point 0, 1. The log graphs always go, because it's the inverse, always go through the point 1, 0. And you can clearly see that they are the inverse of each other because they are reflections of each other in the line y equals x. When you draw in the line y equals x, you can clearly see that log 10 of x is the inverse function of y equals 10 to the power of x, and they are reflections in the line y equals x. If you look at the second set of graphs, you've got the graph of y equals e to the power of x. Remember, e is just a number, 2.71, ... and its inverse is the graph y equals natural log of x. Again, the two graphs, the exponential graph goes through the point 0, 1, and the inverse, the log of natural log of x, goes through the point 1, 0. Again, if you look at the two graphs, the exponential graph has a vertical asymptote at the point y equals 0, which is the x-axis, and the natural log of x has a vertical asymptote at the y-axis, which is the point x equals 0. And why is this? Well, if you look at the exponential graph, there is no value of x that would ever give you a negative value. E to the minus 2 is just 1 over e squared. So it's never going to be negative. Similarly, with the log graph, remember you could rewrite this as y equals log e to the x, and you could change that to an exponential, so you would get e to the y equals x. So there is no y value that could be negative that could give you an x value. So there is a vertical asymptote at the point x equals 0.
Let's go through an example. Let f of x equal 3 log brackets x minus 2. Sketch the graph of f, clearly indicating any asymptotes and axes intercepts. So let's draw ourselves a set of axes. Because it is a log graph, we know we're going to have a vertical asymptote, and we have to work out where the vertical asymptote is. Well, we can't find the log of 0, so the vertical asymptote occurs when x minus 2 is equal to 0, so x is equal to 2. So we have a vertical asymptote when x is equal to 2. So let's draw in our vertical asymptote. So that is at 2. So that is the line x equals 2. This is the x-axis. This is the y-axis. And the second thing we've got to do is find the x-intercept. Well, that occurs when y is equal to 0. So therefore, 3 log x minus 2 must equal 0. So I can divide by 3. So log x minus 2 equals 0. That basically means that e to the 0 is equal to x minus 2. So x minus 2 equals 1. So therefore x is equal to 3. So let's put on our x-intercept. So that would be 3. So our line is going to go up there. It's going to pass through there and up. The 3 in the equation just means that your graph is a little steeper than it would have been if log x minus 2